Okay, uh, in this video, so we're going to look at acceleration. Okay, and so as we all know, so acceleration is equals to changes in velocity over time. So it means there is always must be a changes in velocity. Okay, when we say velocity, so as we it's already explained in the third video, so it's involve direction and also magnitude. Okay, so we're going to look at its acceleration. Okay, so for a linear, for linear motions, when an object is, let's say, start from here with 10 meter per second and it's reach a speed of, let's say, 20 meter per second. Okay, and the time taken is about, let's make it easier, 10 seconds. Okay, so in this case, so it is speeding up to the right hand direction, okay, in 10 seconds. So it means we can say that, okay, the direction of its acceleration is to the right. Okay, so because there's a changes in velocity, 20 will be final velocity, initial velocity, so final minus initial divided by time. So what we are getting is the acceleration to the right. Okay, so from here, if you compare this to the circular motion, okay, so circular motion is circle, it's look horrible. No. Okay, so let's say the car is here, is moving in velocity, okay, and the next position is here, okay. So even though they are moving at constant speed, okay, let's say we use the same speed, 10 kilometer an hour, here also 10 kilometer an hour, but since there is a changes in direction, so we can say that the object or the car has a velocity, and since there is a changes in velocity, okay, then the car is accelerating when it's moving in a circle. Okay, so now from here we know that for the linear, we know that, okay, the direction of acceleration is to the right. Okay, how about for a object that moving in a circle? Okay, this is the center of the circle, okay, with the radius r. Okay, what is the direction of acceleration of this car? Okay, so if you look at here, okay, it's moving somewhere in this direction, and here is somewhere here. But when we calculate the deceleration, we calculate the acceleration, okay, the direction should be, okay, towards the center of the circle, okay, center of the circle. So this will be the acceleration. Okay, when it is here, so the direction of acceleration will be A, towards the center. Okay, and then if it is here, and the direction will be towards the center. Okay, since the acceleration always toward the center, so this A is known as a centripetal acceleration. Okay, so it's always towards the center, so we call this centripetal acceleration. And to calculate the centripetal acceleration, so we use the formula equals to v square over r. Okay, this is the formula that we're going to use. Okay, so if you want to know how we get this formula, okay, so you need to refer your physics module. Okay, so they have stated in your physics module, so we have derived the formula for you. Okay, please go through it, and then if you have any problem, then we discuss further in the next lesson. Okay, now so now we know ready. So it's a centripetal acceleration means it's towards the center. Okay, and then the last thing. Okay, so we look at force. Okay, force is F is equals to ma. This is according to Newton's second law. F equals to ma. Okay, for a linear motion, okay, mass and acceleration is given, then we can find what is the net force. Okay, how about for a centripetal for a circular motion? Okay, for a circular motion, what we do, so this will be same. We're going to use the same formula, F net equals to ma, and now this F net will be equals to m times a. Okay, so since it's a centripetal acceleration, so actually we write with c. Okay, centripetal acceleration is v square bar. So F net will be mass times its acceleration towards the center, we write as a AC. And what we get is F net is equals to m, AC is v square over r. Okay, so this will be the formula. Okay, you all get it? Okay, so for a linear motion, F net equals ma. For the circular motion, the force will be, or net force will be mv square over r. Okay, and then the formula for acceleration is v square r. Okay, so now we recap the whole thing. So what we have learned so far, okay, so we look at linear and circular. Okay, for linear the distance is s. Okay, and for circular the distance will be 2 pi r. I just take as a linear is L, and for this is 2 pi r. Okay, number 1. Okay, the speed will be L over t, distance over time. For this the speed will be 2 pi r over t. Third one, acceleration is, we write with a. Okay, for this the acceleration will be centripetal, known as a centripetal acceleration, and be v square over r. And lastly, number 4, F equals to ma, and this is known as a net force. And for circular motion, we call this F net equals to m v square over r. Okay, so that is how we differentiate these two, linear and circular. Okay, since this is due to the centripetal acceleration, this also, or net force, also known as centripetal force. Okay, centripetal force or net force. Okay, or resultant force. Okay, all these are the same meaning. Okay, so we have done up to the basic or the introduction to the circular motions. Okay, so in the next few lessons, so what we're going to look at is, first one we look at horizontal circular motions. Okay, means when the object move in a horizontal, but it's move in a horizontal circle. So now we're going to look at the quantities that are going to be changed. And the next lesson we're going to look at circular motion, but it's in a vertical way. Okay, for example, like a Ferris wheel. So all these are moving in a vertical circle. So when they move in a vertical circle, so what are the changes that are going to happen? So same like when for a linear, when we have a horizontal and vertical motion. Okay, so same as that. Okay, and then after that we're going to look at universal gravitational law. Okay, then we look at the Kepler's law, where it is related to all the planets, and also we can calculate so many things, satellites and so many things. Okay, so that will be our lesson for this topic. Okay, Kepler's law will be the last part of chapter 2. Okay, yeah. So we end the video here. Okay, Thank you for listening and also learning. Okay, so good luck to all of you.